list, like in the front one?
That's right. So in the linked list, we're actually getting into a little bit of code, but that's perfectly fine. The question is, what is the data type of front? We're going to have a private piece of data called front. Thanks, Trish. So what is the data type of front going to be?
Node.
Say again, Henry?
It's a node, right? Yeah.
Right? Does that answer what you're talking about, Sarah? Front is a reference to a node.
Okay, I guess what I'm confused about is where you're specifying that we're talking about strings.
That's the E, right? Like, just like when you make an array list, you have to say what data type by specifying the type parameter. Here, when you created the linked list, that's when you would do that, right? So
got it. When you're instantiating the linked list, like in some other class, then you're going to, okay, got it. I'm sorry, thank you.
Nope, that's quite all right. Right? This is the moment where that becomes a thing, right?
Yeah, that makes sense to me now. Thank you.
Yeah. And, you know, the old slides used to have things that didn't have the generics, but I figure, you know, we're already into generics. We understand them enough to just, you know, move a little bit forward. But yeah, that's where that becomes real. And in the diagram, that's literally how we'd show it, right? In a linked list diagram. In fact, by the way, this is the object diagram, right? This is how a linked list object diagram looks like, right? So in this case, this is a linked list that was instantiated as a string linked list, right? So the generic has now been resolved at object time, right? And all of these have in fact been resolved, right? They've all been resolved. They are now strings. And so then all of the data type, the data references are all resolved because they point to strings, right? So that type parameter has locked all that stuff in together. Okay. All right. What else, folks? Okay, I'm going to look and see, is there one more thing that we need to do? Okay, I want to make sure though, before we do that, are there any other questions? Because I don't want to move forward unless everybody's on the same page, feeling reasonably good about this stuff.
I have a question about remember you said when we have just each item pointing to the next item, and if we bring a new item, if we don't watch how we do it, then we will lose some items. So is that true also if we have an item pointing or a node pointing to the next and it has two links or two hands or whatever, still we have that issue?
That's a great question, Idris. If you have a doubly linked scenario where one student's pointing to the next one and also to the previous one, it's harder to lose people. It's harder. It's not impossible, right? Because if you stop pointing in certain ways, you can still lose them. But if you've got two of them, you're less likely to be able to do that because somebody's probably got a hold of somebody, right? So it turns out to be, it's a little more forgiving code. You've got more references to deal with, right? Because now you got a new guy coming in. You've got to have this guy pointing to here and this guy, like you've got to remap now 4 pointers instead of 2. But the order of them can be a little more forgiving because it's very likely that somebody still got a hold of the other person, right? So the order is a little less precise in those cases. That's a good observation. Yep. All right. Anything else you guys want to chat about?
So just clarifying here, you said that front does not have a next, right?
Front itself is not a node, so front itself doesn't have a next or a data.
So it's just kind of a tag saying this is the front.
It's the starting point. That's right.
Just checking.
So you've always got to jump in and go there, and then in the nodes you can do the data and the whatever, right?
Cool. Yeah, just checking. Thanks.
Yep. And the other thing is, it's also a special case because if you have an empty list, what does front point to?
Null.
Null. So in almost all the code we write, one of the first things we're going to do is say if front is null. Because if front is null, that's a special case. We have an empty list. We better not take one step, right? We can't even move one step toward a node because we got an empty list. So there's almost always that special case code that says, yep, always check whether we got an empty list if front is null. Then we can start a loop that processes nodes, right? Because nodes are all the same, right? They're going to just be loopy, loopy, loopy. We treat them all the same. Front, we got to treat a little specially. Yeah, Ben, go ahead.
Yeah, so I'm a little bit confused about what you said. You said the front itself isn't a node, but it definitely points I think what I'm confused about is a special type of node that
It's,
doesn't.
yeah, it's not a node. It is a reference to a node, which is different than being a node. Right?
Right. So, but when you like had the code on the notepad,
Yeah.
you had the
Yeah, that is a reference to a node.
yeah, that's a reference.
That's not the same as this object, which is a node object and has a data and a next in it. Right?
Right. Yeah. So it's just going to be pointing to whatever.
That's right.
Yeah. Whatever. Okay.
But that one small distinction is all the difference in the world, and it means that we are forced to treat it differently every time.
Yep.
We can't start the loop yet. Like we literally have to start at front and always do this, what seems like an extra step of saying, wait, is front pointing to null, right? Because I can't step foot into the rest of the list if it is, right? So you always have this little extra special case because of this difference. Okay, make sense?
Mm-hmm.
Okay. All right. All right, so we're out of time, but I think we got a lot of these concepts started well today. And so tomorrow we'll start looking at the different operations and we'll start writing some of the code together. And